Okay, so I just want to go through a couple of problems from each section of the homework. So we're in the packet on page 371. Our first section is asking you to find the frequency, the period, which is abbreviated T, remember that is the period, from the angular velocity. So remember, angular velocity is equal to 2 times pi times the frequency. So the frequency, if you divide by 2 pi, is the angular velocity divided by 2 pi. The period, remember our period is always equal to 1 over the frequency, reciprocal of the frequency. So I'm just going to pick a number, let's do number 5 here. Number 5 is 380 radians per second. Find the frequency. Just take 380 divided by 2 pi. So 380 divided by, now we have to put 2 pi in parentheses here. 2 times pi. It equals, we get 60.48, we'd round that to. That is hertz. Might even round it to just 60 hertz. Our period then is 1 over the frequency. So that's 1 over 60.48. 0.0165 seconds, or 16.5 milliseconds if you want to look at it as milliseconds. Either one of those is fine. Any questions on those? So the next section there wants you to find the period and the angular velocity from the frequency. Remember, the period is just 1 over the frequency, reciprocal of the frequency. The angular velocity is 2 times pi times f. So again, I'm just going to pick one there. I'm going to pick number 19. 19 is 500 hertz. So our period is 1 over 500. Or 0.002 seconds. Or 2 milliseconds, if you prefer. Omega, the angular velocity, is 2 times pi times the frequency. So 2 times pi times 500 is 1,000 pi radian per second. Or if you wanted to multiply it out, it could be 3,140 radians per second. Either way. Any questions there? Yeah. Or if you use the pi key, it might be 3141.59. Any variation of pi times 1,000 will work. For the next section, they want to find the peak value. So that's either I peak or voltage peak, depending on what we're talking about in the equation. They want you to find omega, the angular velocity, the frequency, and the period for each of these. We're going to do a couple of these. So we're looking at number 29. We get 110 equals, I feel I should include the V equals 110 times the sine of 140 pi t. So the peak is always this number multiplying the sine. So the peak is 110. It's in volts, so that's it's voltage we're looking for, so that's 110 volts. This right here is the angular velocity. 140 times pi is the angular velocity. 140 pi radians per second. Frequency is found by taking that angular velocity divided by 2 pi. Well, the pi's cancel out. What's 140 divided by 2? 70 hertz is our frequency. Our frequency, or our period then, is 1 over the frequency, 1 over 70, which is going to be 0.0142853 approximately. We're going to go 0.143 is where we're going to round it. That is seconds. So either 0.0143 or 14.3 milliseconds. Does that make any sense? Okay. Then we're going to do number 33. Number 33 is I equals 0.45 sine of 500 t. Our peak is still the number multiplying the sine. 0.45. Now this is current, so that would be amps. Angular velocity is the number multiplying t. It's 500. That's going to be radians per second. So again, those two parts read right out of the formula. Frequency requires some work. Frequency is that angular velocity of 500 divided by 2 pi. There's no pi to cancel out here, so we're going to have to just calculate it. 500 divided by, I'm going to enter 6.28 is 2 pi. $79.62 hertz. So our period is 1 over the 79.62, 0.01256. Seconds, probably round that to 12.6 milliseconds or 12.56 milliseconds. If you want to leave it that way, that's fine. This part it doesn't have to be, but if you're actually trying to, put a number in for t, yes, it would have to be. Yep. So let's look at number 39. 39 gives us a sine wave. This is 160 volts, negative 160 volts. This is 8.0 milliseconds, 16.0 milliseconds. What is the period? Perfect, 16 milliseconds. Or 0.016 seconds. Either one is fine. What is the amplitude? 160. I wrote it small. 160 volts. Frequency. Our frequency is 1 over the period. So 1 over 0.016. That does have to be, the period does have to be in seconds for the frequency, just so you know. That's 62.5 hertz. What is angular velocity, omega? 2 times pi times f, otherwise known as 125 pi radians per second. What do you think? Not so bad? Good. Let's do number 41. Number 41, we're asked to write the equation of the AC sine wave with a given condition. Our peak voltage is 180 volts. Our frequency is 60 hertz. So that means our voltage is always the peak that multiplies the sine, so 180 times the sine. What goes in here is always omega, which is equal to 2 times pi times the frequency. That's going to be 120 pi times t. But what if we go to something like number 45, where we're given a little bit different information? Here, of course, this is a current. We're given that the peak current is 450 milliamps, which we're going to convert to 0.45 amps. Need to stay in amps. We're given that the time, the period, is 15 milliseconds, which again, we're going to convert to 0.015 seconds. So now our formula requires the frequency, so we can use the period to find the frequency of 1 divided by 0.015, 66.67 hertz is our frequency. So now our equation, the instantaneous current, I, equals the peak current, which is 0.45 amps, times the sine of that's part of it, yep, times 2 pi, right? Remember, it's omega that goes in there, which is equal to 2 times pi times the frequency. Now, since this is already a decimal, we just want to multiply the whole thing out, right? So 2 times 3.14 times, I was doing that previous answer. So 418.67. T, little t, which is for time. That's it. Any questions there? Let's look at number 49. Number 49 is asking us to sketch the AC wave for one cycle. Well, V equals 340 times the sine of 100 pi t. Our AC wave goes to positive 340 volts down to negative 340 volts. That comes from this here being our peak voltage, the 340. Now we need to find the period. The period, of course, is the reciprocal of the frequency. The frequency is the angular velocity, omega, divided by 2 pi. This is omega. So our frequency is 100 pi divided by 2 pi. What's that give us? Well, the pi's cancel out, so yes, you have it, just 50. So the frequency is 50 hertz. So the period is 1 over 50, or 0.02 seconds, or 20 milliseconds. So I'm going to put this here as 20 milliseconds, this here is 10 milliseconds. The sine wave, halfway in between there is going to peak. Halfway in between here is going to hit its minimum. So there's our sine wave. There it is. Not so tough. I'm going to have you guys try one. You guys try number 51. I was going to go easy. I'll try number 50. 50 is instantaneous voltage equals 170 times the sine of 120 pi t. Graph that for one cycle. So really the two pieces of information we need is the peak, which is going to be these values right here. Where do we find the peak value? You got it. It's the number multiplying the sine, the 170. This is 170 volts. This is a negative 170 volts. Now then, to find the times that go down here on this axis, we first find the frequency, which is omega over 2 pi. So omega is the number that multiplies t inside the sine. So it's 120 pi divided by 2 pi, which gives us 60. Yes, the pi's cancel out. We got 60 hertz. T period then is 1 over the frequency. So it's 1 over 60, or 0.0167. So that's seconds. So we're going to call it 16.7 milliseconds. So this here is 16.6 16.7 milliseconds. This here is going to be 8.35 milliseconds. You got it. That's it. What do you guys think? Okay. Now let's look at a couple of problems. Now, these are the ones where you're going to have to make sure your calculator is in radians. So problem 57. Given the AC voltage wave, V equals 160 sine 120 pi t. Part A, find the voltage at 7.0 milliseconds and also at 1.5 milliseconds. So for 7.0 milliseconds, that voltage will be 160 times the sine of 120 times pi times 0.007. I'm going to make sure my calculator is in radian mode. So 160 times the sine, 120 times pi times 0.007. It's 77.08 volts. I want you guys to do it for 1.5 milliseconds. So it's going to be 160 times the sine, 120 times pi times 0.0015. Or 85.73 volts. Okay, so any questions on that part? So part B, the two values of T in the first cycle were in volt. The voltage is going to be 100 volts. So what we're going to do is we're going to find the first value where it's 100 volts. The second value will be a little bit easier to find. I'll show you how we find that. So the first value of T, where the voltage is 100 volts. Now when 100 goes in for V, it's still 160 times the sine of 120 pi. It's just we don't know T, so T is just going to be T, the variable. Now we solve for T, we've got to get the sine of the trig function by itself first. We're going to divide by 160. So that's 0.625, I believe. Equals the sine of 120 pi times T. Now, we've got to get rid of the sine, so we're going to do an inverse sine. Inverse sine of 0.625 is 0.6751. So the sines have canceled out here. This is 120 times pi times T. To get T by itself, we divide by 120 pi. So we divide by, in parentheses, 120 times pi, close the parentheses. 0.00179 equals T. So that's telling us is it reaches 100 volts here at 1.79 milliseconds. We need to know this time right here. We know the period of this. So the frequency is going to be omega divided by 2 pi. So that's going to be the 120 pi divided by 2 pi. The pi's cancel out. 120 divided by 2 is 60. So the period is 1 over the frequency, which is 0.01667, right? Seconds. That makes this time right here 16.67 milliseconds. This time right here is 8.335 milliseconds. Why is that important? Well, because if it was 1.79 milliseconds from here to here, the point over here, where it's also equal to 100 volts, is going to be 1.79 milliseconds from the end of that, from that equilibrium point, from the 8.335. So 8.335 milliseconds minus 1.79 milliseconds. 6.545 milliseconds will be that second spot. So 1.79 and 6.55. What do you think? They're confused, Jeremy. If I only asked you for the first spot, would you be able to find this one? Okay. On the test, I only asked you for the first spot. But because this is symmetrical here, this is just the same distance from here as it is from here. Just half of the period. Yeah. Yep, it's always half the period. It's always t over 2. I'm gonna have you guys try one of these on your own, then we'll call it a day. So it's actually number 59 out of the pack. So for the equation, I equals 2.0 sine 100 pi t. Find I at 17 milliseconds and, oops, not 17, 8 milliseconds. I read the wrong problem. At 8 milliseconds and 1.5 milliseconds. Then it's going to have you find the first time that I equals negative 1 amp. I'll give you guys a couple minutes to work on that. Okay, so let's look at the first part here. For 8 milliseconds, of course, it's just I equals 2.0 sine 100 pi. What goes in for t? 0.008. Good. What'd you get when you calculated that out? 1.176 amps, that would be, right? Okay, so then for 1.5 milliseconds, that's I equals 2.0 sine 100 pi times 0.0015. What do you get? Okay, 0.908 amps or 908 milliamps. Perfect. Now, the first time that it equals negative 1. So negative 1 goes in for little I equals 2.0 sine of 100 pi t. So we're solving for t. Divide by 2. So we got negative 0.5 equals sine of 100 pi t. We're going to do an inverse sine. Now, some calculators give you a little different answer here. So what answer did your calculator give you? An inverse sine of 0.5. Negative 0.524 radian, of course. That equals 100 pi t. So of course we've got to divide by 100 pi. So negative 0.524 divided by, now you could have also just done divided by 100 and then divided by pi. I did divided by and then in parentheses I put the 100 times pi. Okay, negative 0.00167. That's the time. Problem is that's negative. That's not during the first cycle. So let's find our period here. To find our period, we're going to find the frequency first, which is the 100 pi is omega divided by 2 pi. That's just going to give us a frequency of 50 hertz. Our period then is 1 over 50, 0.02 seconds, or 20 milliseconds. This over here, negative 0.001 is negative 1.67 milliseconds. So we combine that, negative 0.167 milliseconds. That's saying it's 1.67 milliseconds before the end of the cycle. So 20 milliseconds was the full cycle. 1.67 milliseconds before that is 18.33 milliseconds. Is the time that we would get that. The question is that the first time we would get that value? Since we were going from the end of the wave, the first time we hit -1 is right there. There's a first time over here. This was 20 milliseconds. That was our period. That makes this point here what? 10 milliseconds. So then from there, we could add the 1.67. This point would be 11.67 milliseconds. Because we're going forward from that point, we subtracted from here, we add from here. Because if we subtracted, that put us back here. And there would be at 8.33 milliseconds, that'd be a positive 1 amp. It would be 1, but it would be positive. Okay, I'm going to let you guys off the hook with no homework tomorrow. Tomorrow we're going to finish up the unit. Thursday will be our unit test.